So today with us we have Hardik Pawar. He is a student of CSC third year, and he is proficient and well versed with machine learning, and he's also interested in computer vision. More about him, he'll himself say. I'm just here to say a brief introduction about him. So he has built a emotions detector project that he'll be discussing with you soon.
Check, check,
And
check, check.
with by saying that, over to Hardik. The session's yours. Explain away.
Yeah, thank you, Devam. Hope I'm audible and visible both.
Yes, you are.
Yeah, so to reintroduce myself, I'm Hardik Pawar from RVCE, 4th semester, Computer Science and Engineering Department. Sagar sir had suggested me to take this session on emotion detector because when he viewed my projects, he was particularly fond of this one. And it was his brilliant idea to inspire the young minds of the first year ISC, the members of the coding club, and RVC students. So, without any further ado, I would like to start with the presentation. Hope my screen is visible.
Yes, it's visible. You can go
Okay,
ahead.
I'll go ahead. So, yeah, let me start with the emotion detector project by me. I'll just admit, yeah. So, what is the broad content of this presentation? Firstly, we'll take the introduction to what is this project about, the tech stack and the frameworks used to build this project, the methodology of how this project works, the step-by-step guide for a layman to use this website. The fifth is the live project demonstration. Sixth topic is the additional resources and link to the actual code base of the website and the Jupyter notebook for viewing how the model was trained. And last but not the least is the most important thank you slide. So let us start with the introduction. So what is Emotion Detector? It's basically a responsive web application that uses computer vision and deep learning to detect facial emotions in real time. Users can interact with the website on their laptops or mobile by turning on their webcam, taking a snapshot of their face, and sending that image to the machine learning model to detect their emotions in real time. So now let us dive deep into the framework technologies used to build this website. So I've classified the tech stack into three components: the front end, back end, and version control system. In the front end, the basic languages used are HTML, CSS, and JavaScript, and the styling framework used is Bootstrap. ScrollReveal.js is an interesting JavaScript framework which I'll show you for its beautiful animations. In the backend, I have used Flask, which is the Python micro framework for developing web applications. Along with that, I've used OpenCV, in particular the CV2 version, which is, if you're familiar with it, it's used for computer vision, this library, and NumPy for again image processing, cropping of the image, TensorFlow, Python imaging library, and Base64 to handle images. Like instead of dealing with the image in JPEG format, we convert it into Base64. And Git and GitHub have been a lifesaver truly because I have used them for tracking version control. Like anytime I added any new feature, let's say a new font, a new text style, or new functional component, I committed those changes and saved them in GitHub. So anytime I messed up or an error occurred, I could just roll back to the latest previous stable version. Admit all, yeah. So now let us explore the intricacies and the inner workings of this website. So step 1, the user records a snapshot of his face and then first he opens the webcam by pressing the play button, and then when he presses the snap button, the snapshot of his current face is sent to the Flash server. In the Flash server, we first convert the image to grayscale. Originally it is a colored image with RGB coloration. We convert it to grayscale. After that, we run it through a har cascade classifier, which is an XML file that is used to detect faces in a grayscale image. And out of the various faces detected, we only take the first face and then we crop the image to that particular face itself. Basically, using NumPy resize function, we just delete the entire background and focus on make the foreground, which is the face, as the main focus. That I covered that in the fourth step. In the fifth step, the model takes this process image and then gives actually 7 predictions. Out of that, we take the maximum value of the emotion as the final predicted emotion. There are 7 emotion classes which the model can detect, which are anger, disgust, fear, happy, neutral, sadness, and surprise. In the computer vision part, we detected the face. Around that, we put a green rectangle, and above that, we overlay a text which displays the predicted emotions such as happy, neutral, etc. In the second last step, we send this processed the result image back to the front end application via the JavaScript API call, and then in the website we display the original image and resultant image side by side. So now let us go to the live demonstration of the website. So this is the home page of the website. Over here is a cool sliding animation wherein if you slide over here, the happy face turns to sad face to happy face, etc. Just a cool little toggling effect. And this is just the above arrow is just for giving the user an idea that this area can be slidden into. As you remember, before I had mentioned that about scroll reveal.js library, and that is the one that is used for making this list animation. So whenever it's out of view, the bottom list steps are blank, but afterwards they slide into the animation. So now let me start with the juicy part about the demonstration. So when I press play, the webcam starts. I press snap. The image is processing and being sent to the machine learning model, and here I have a response which says surprise. Quite surprising. Over here, give me a second. Yeah. Over here I have a card div where if you want to explore more about the project, you can do so by clicking here. If you want to explore how the machine learning model was trained, the dataset and the images involved, you can click over here. And if you want to view my GitHub profile, the link is over here. I've just added some cool golden hover card effects here just for styling purposes. And at the bottom part of the website is the footer section where it briefly describes in a nutshell the model used and how the website works. It was trained on 35,000 images. It is a convolution neural network, and as I said before, the frameworks used to build it. And these two links are the first link is for the machine learning model and the second is for the code base. So when you click on those links, the respective GitHub repos will open. I'll link this afterwards in the WhatsApp group if you want to explore more or want to, for that matter, clone and contribute to it. This is for the Emotion Detector code base, the entire website. And over here is the Jupyter notebook for how the machine learning model was trained. At the end of the session, if anyone wants, I can go through the code base and the model, the Jupyter notebook, if you want me to go through it. So now let us continue with the PPT. Yeah, so as I had reiterated, the resources, you can explore the Jupyter notebook if you want to know if you want to dive deeper into how the data was pre-processed, the model architecture, which all neuron layers, the convolution layer, the pooling layers were involved. And if you want to see the entire code base, you can go to the GitHub repo, which is linked over here. So with that, we come to the end of the concise presentation. Now, if anybody has any questions, I'm willing to take it. Yeah, so any questions? Okay, let me see the chat. The website isn't visible. Never mind, it's my identity. Can I go through the Jupyter notebook? Okay, sure. I'll open that up in my VS Code. Sharing the screen again. The screen is visible, yeah. I'll just open a new window in VS Code. Yeah, the notebook is loading, and here we have it. You can ignore this. Okay, there's a chat message. What was the process of learning all this? Okay, I'll go to the Jupyter notebook, then I'll answer this question. Yeah, you can ignore this cell because what it basically does is just checks if this scikit-plot library was installed or not, and if it was not installed, it just reinstalls it in the command line. So yeah, In this cell we have all the external libraries used, the famous ones which you may be aware of, such as pandas, numpy, scikit-plot, etc, 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 all the ones that were used. In the first step, actually what we do is load the data set, which is located over here. It's actually a CSV file with the pixels marked as column numbers, and this data set was downloaded from Kaggle. The data.head method statement, what it does is just prints the five rows of the entire data set. Okay, so this what we do is we segregate the class labels, which were the 7 emotions I said before: anger, disgust, fear, happy, etc. The data pre-processing step, and here we just set the x and y and title for the graphs, for each of the graphs. As you can see in the data set, the happy emotion is the one that's present in abundance, and so if after the presentation, whenever you try the website and you go for the detection, most of the prediction will either be happy or surprise, because those were trained in abundance over here. Very fewly you will get, in very rare cases you will get disgust, and I've not got it even once. So yeah, I'll just go briefly through it. Yeah, here we standardize the data such that, as you can see, the pixels will have value between 1 to 255, 0 to 255. Here we just fit the model between 0 to 1. So we scale it down such that all the ranges get fitted between 0 to 1. Reshape the data just for that's how the TensorFlow model works. And here what we do is, you can just ignore most of the noise and focus on this part, the train test split. What it does is, it splits the data into training data and test data. And over here I've given test size as 0.1, which means 10% of the data will use for validation, basically checking the accuracy of the model, and 90% will be used for checking for training the model. Over here we have just plotted randomly 7 images of just seeing the data set, like for neutral, which is the corresponding phase, for fear, which is it, for happiness, which is the phase, etc. Here is the important step that we are doing is data augmentation. So what it does is, basically if we have one image, it manipulates that image such that we can generate 10 more images from that same image, and consequently increase our training size. So what it does is, if an image is, let's say, 100 into 100 pixels, the width shift range will basically equal to 0.1, will basically shift it 10%, plus minus 10%, change the width, flip the image, etc., so that our model is more diverse and can accurately predict the face, even if it's flipped vertically, horizontally, etc. So here is the model. Before that, let me admit someone if they're waiting. Nope. Yeah, so these are all the layers involved in the deep learning model. The convolution layer, the dropout, that's just basically that to prevent overfitting of the data, those many percentage, like 25% of the neurons will be dropped out. That's just for preventing overfitting and leading to lossy accuracy. We have also added pooling layers and flattening layers over here. Just to give a very layman's explanation, pooling layer, basically what it does is, if we have a 100 into 100 matrix, it basically converts it into a 10 into 10 image. There are many various techniques used, such as maximum averaging and medium averaging, according to which it basically converts the entire neighboring pixels into one single pixel. And the flatten layer just does what you think it does, converts a 2D or 3D array into a single long vector, one-dimensional single long vector. So yeah, this model is defined in this function. We call that function, compile the model, and the model summary can be viewed here, which all layers it has. And in this part of the function, we train the model for 30 epochs, which is 30 cycles. And I ran this model training on my laptop, which has an NVIDIA GTX 1650, and it took around 15 to 16 minutes to train this. So after training, the results can be visualized over here. The one with training data is marked with red, and the one with the 10% test data is marked with blue. You can see the accuracy almost coincides over here. The model accuracy was actually 62.24%, which is not that bad for an image detection model. If we are going for linear regression or logistic regression, an accuracy above 80 to 85% is favorable. But this is not too bad for an image recognition model. Here what we have done is in the we have used the test data, and we have ran the predictions and plotted the predictions for the how good the model is performing. As you can see, for happiness and surprise, most of the predictions are correct, but for rare emotions in the dataset like neutral, disgust, the output is erroneous. So this is just the confusion matrix that plots the actual emotion that is present for the image and the predicted emotion. And this is just the F1 score, precision, recall, etc. There are many mathematical definitions for this, like true positive by true positive plus false negative, etc., etc. But that you can just Google it and you can dive deep into that one. And last but not the least, the hard work, the 15 minutes of hard work that were involved in training the model will be saved over here, which will be used in the web application, the final .h5 file, which is of course not directly viewable. So now let me see the chat for the next question. What was the process of learning all this? Like, where did you start? Okay, to give a brief background, during my first year of college, I did many Udemy courses covering fields like web development, machine learning, C++, computer vision, and as part of the OS course, I had done the Linux multi-threaded kernel. So I always had the curiosity to explore, to keep exploring and exploring more, and the idea for this emotion detector website didn't come that didn't come in my dream. There were many mini projects before this and sub projects involving each particular category, like one project of web dev, one of ML, one of computer vision, etc., etc. This has been this project is actually close to my heart because it combines the three fields of web dev, ML, and computer vision in a beautiful package and presented as a beautiful front-end web application. So yeah, most of it has been trial and error, and there have been many failed projects before the ones that come out. There have been many failed projects in order for the truly good ones to come out. So yeah, any more questions? Feel free to unmute, or you can type in the text box if you're not feeling free. How long did it take you to build this? I can actually give you an accurate, screen is visible, yeah. I can actually give you an accurate number, because if I go to my GitHub repo, if I go to my GitHub repo and go to the commit section, it will give you the date, the start date when I started this and when I completed this. So I started this on April 15. That night for like 9 to 1 p.m. 9 p.m. to 1 a.m. I was doing this. April 16. By April 16, I think most of the functionality was done. The next day what I've done is only the styling parts. So that has been 2 days, 1 day, and yeah, the totally in 4 days I did this. More or less 4 days. Like at the starting, during the first day, I only focused on the functionality. I didn't even think about the styling. Like what good is styling if the basic website doesn't work? But at the end of the day, when the user sees the website, he wants good UI UX. So that's why at the later half of the development, I focus on building a good UI. All these cool styles. Any more questions? Yep, recording. Oh, by the way, okay, how did you choose the right data set? Actually, this Jupyter notebook that I had made, it's already available in Kaggle. I just fine-tuned and tweaked it to my preference. Like I skipped many of the pre-processing steps. That's why the accuracy of the model is less, because I wanted to try it on my own. So the dataset is already available on Kaggle, but I don't know if I'll find that exact Jupyter notebook. If I find it later, I'll send it to you, but I'll have to search where it was. Yeah, in the presentation I told that if you want to contribute to the project, what you can do is you can go to the GitHub repo the one that will be sent in the presentation itself, the link. You can fork it. I can't fork my own repo. You can fork it, clone it on your local machine, and you can give your contributions via pull requests. Like suppose you wanted to add the README, or you wanted to add a design to the website, or you found some bug in the Flask API and you wanted to fix that or improve the performance. Any contributions are always welcome. Ready for questions anymore? Or if you want, I can directly explain the Flask code base if you want. Do you have any ideas on extending this project? Yeah, actually, the one immediate idea that comes to mind is right now it just takes, when the user switches on his webcam, we just take a screenshot or snapshot of his face and then we predict it. But as you saw, even for that one snapshot, the model takes a good 3 to 4 seconds to give an prediction. So the next obvious step might be to do it for a live video feed, like continuously improve the models in such a way that in millisecond, in a fraction of time, it can give the prediction. So then instead of to a screenshot, we can apply it to a video feed. So I think that can be the immediate extension of this project. Where could we apply this in the real world? Okay, so in China, one interesting article I came across a few days ago. In China, there's in the classroom there are cameras attached where they can monitor the children's face and see if they're drowsy, sleepy, excited to learn, etc. And accordingly they can map how the students' attention level spans over time, and like that they've decided the optimum time for when classes should start, etc. So that can be one application, I feel. So yeah, I had this one doubt whether the data you collect while training integrates with the data set. The entire data set as a CSV file, it's downloaded from Kaggle, so there was no hassle of collecting the data from elsewhere or any third party. I didn't show the CSV file only. Aha, this is the CSV file. There are 3 columns: emotions, pixels, and usage. This is the emotion, the number, and all these are the pixels in one straight line. So yeah, directly from there. It's still 9:28, not even half an hour. I think I'll go with the in-depth code analysis of the Flask server.
Hardik, hello.
Hello,
So
yeah.
I just have one question.
Yeah.
Like building projects regarding to OpenCV, like computer vision and all, we just call many of the built-in functions, right?
Hmm.
So like, have you like gone into the code of it, like what exactly is being done in that? Because the math is pretty tricky, right? I mean,
Hmm.
as far as I know.
Yeah.
So, like, have you gone into the depth of like what each library does or something like that?
No, like OpenCV, I didn't do like first study OpenCV theoretically, like which function is which. As and when I
Mm-hmm.
needed a functionality, I just used that particular method and function. Like in the before presentation, I told that for cropping the image to the face,
Mm-hmm.
the OpenCV library for that I used, like I googled how to crop this to the particular pixel if I have the 4 coordinates, the x, y, width, height. So as and when the problem arised, I just googled stuff.
Oh, okay.
And I
Thank you.
felt like that was like a more practical approach to learn, because when you have a problem and you're not getting the solution and you google it, in that way you can remember the solution much in a much better way than directly learning from the start in a theoretical way.
Thank you.
So yeah, so I think I'll go with the project, the code, actual code based explanation. All these over here are the boxes, the buttons, the play, close, snap buttons. I'll go to the main snapshot area, which is over. One sec, I'll find it. Over here, yeah. These are the play, close, snap buttons. So all they do is, on clicking, they call the respective function in JavaScript: start webcam, stop webcam, take snapshot. Now here is the main part of the website. Screen is visible, yeah. These 2 JavaScript functions are basically that super slider effect, that happy sad face that you saw, and the second one is that scroll reveal, the steps that load up when you go into the website. these steps. Yeah. So here is where the fun part starts. Over here we declare three variables related to the webcam: video, canvas and stream. Canvas is the variable used when we take the screenshot. So when the user presses the play button, this start webcam function starts. It basically gets the webcam, and if there has been no error, in case there has been error, it just says error accessing camera in the console. If there has been no error, this part of the code is executed. So what it does, it captures the stream from the camera. In the HTML video tag, it embeds that stream and plays the video. And if you notice one thing, whenever I press the play video in the website, the title changes from webcam to the webcam plus this red dot, which is done using this statement. I'll show that if you didn't observe. See, the webcam is on, the red dot is there. If I close it, the red dot disappears like that. The stop webcam function just stops the video stream, sets the video inner tag as null, and it changes the title back to webcam. Now this is where the model prediction result is received. Whenever the user presses the snap button, we store the width and height of his current snapshot in these canvas inner variables, and then we send the image data using this send snapshot function. Now what this does is, when the user presses snap, the model takes some time to predict. So while the user is waiting, we display the loading animation, the beautiful hexagon dissipating pattern, which if you didn't observe, I'll show again. I press play, snap, this pattern. A good 3 to 4 seconds and it will display. Yep. Wait, let me close that webcam. So what it does is, to this route, we send the image data as the part of the JSON body. And then when we get the successful response, we just convert that response to JSON, and then we process that JSON over here. At the start, when the data is not yet, we have sent the data to the server, the loading animation starts. When we receive the data successfully, the loading animation is stopped here. Over here, we do the displaying of the original and result image side by side. We just select that div component in the HTML over here, and then we add that image source as the original image. Similarly, for predicted image, we add it over here. This part of the code basically works when no face is detected. It just displays an error message on the website. So this was the JavaScript function. Now let me go to the app.py, the Flask server, the Flask API that handles all this. The default root of the website is just a simple slash. What it just does is get the current year and renders the home page index.html. So why am I doing the current year? That's simply because in the footer section, I just want the current year to be displayed. So next year I don't have to come here and manually type 2024 2024. It will just automatically update the year over here. Copyright, the very important copyright. So yeah, how this works is, in the JavaScript function you saw, we send a post request to the /snap image route. In that route, we receive the image over here using the request.form.get, and then we use the image processor library, which is just my custom Python script, which is right over here. I just modularized it into a different Python file because these libraries, I could have imported them over here itself at the top and given this entire logic right over here. But what it does it was delaying the website response time by a lot. It used to take like a good 20 to 30 seconds to even load the website. But after I shifted the imports to the image processor.py, which runs only if the user presses the snap button, the website loads almost instantaneously. So let me go into, we receive the data, we process the data and just return the JSONified version of the response. So now let us go into how the image is exactly processed. Using the cascade classifier, which I told was har cascade frontal face classifier, we load that classifier, decode the image data, convert the image to numpy array, do the color correction for the image, detect the face in the image using the face cascade classifier, the har cascade one. We get the first face from the list of faces, and then we draw a rectangle around the face using the x, y, width and height variables. And then what we do is we resize the image and convert it to an array, and in this part of the function we send the response back as a Python dictionary. And here also the response is actually a Python dictionary. JSONify just converts it into a JSON string, which is later unpacked in the JavaScript function. So yeah, this was the code base for Emotion Detector. So I have finished explanation of the Jupyter notebook and the code base too. So any more questions? You can feel free to unmute or type in the chat. I think I'll give an additional info over here. Since this is a Python, this Flask is a Python micro framework. All of it has been done using Python. So what you can do is if you have Python globally installed on your laptop, instead of using that, you can use the .vim virtual environment, because it will handle the package dependencies, the package conflicts, the package version conflicts with each other. This basically creates a local version of Python for that directory itself, wherein only the necessary libraries you can pip install and then work with the same. And at the end of it, you can just create a requirements.txt file which shows all the libraries used along with their version. So the advantage of this over using a global Python interpreter is that here if someone wants to re-simulate your project, they can just clone the repository and type pip install -r requirements.txt, and the exact modules with the exact version number will get downloaded. So yeah, that is a plus. And for anyone wondering, the Python version that I use is 3.10.4. I tried using 3.11, but then libraries like TensorFlow also were giving a lot of errors. Like TensorFlow is not available, etc. So I just shifted back to 3.10.4. One question has come here. Do you have any recommendations for us if we want to start learning ML? Yeah, actually there's a Udemy course on machine learning by this guy called Joe Sportilla. Joseportilla. Machine learning, Joe Sportilla, Udemy. This one I felt was like a really nice comprehensive guide to understand machine learning. I think it's this one. Yeah, this one only. It basically covered all of the famous machine learning models like random forest, decision trees, CNN, ANN, RNN I didn't do. Only CNN and ANN, logistic regression, KNN, K nearest neighbors, K means clustering, etc. So I think that is a really good place to start. And at the start, he also explains pandas and NumPy, how to do data manipulation with that, how to, like, what is a data frame? Data frame consists of series, etc. It gives a very nice intro to that. Questions.
Hello, Hardik. So
Hello,
you
yeah.
said that. Hello.
Yeah.
Yeah. So you said that you have trained the model on two emotions primarily, that is happy and surprise.
Yeah.
Now, what if you get a third emotion? Is the model expandable to learn a third type of emotion, or would you need to deploy another model to learn the same?
Actually, now it can detect 7 emotions, but the one once it can detect with the most accuracy are the two ones, happy and surprise. So mostly the emotion that is very rarely present in the dataset is, let's say, disgust one. So if someone gives an input image of disgust, mostly the model will predict it as either sad or anger, because that particular emotion is very less trained on. So it will give an erroneous output for the lesser trained emotions.
Okay.
Oh, by the way, I had made a YouTube tutorial before on how to fork clone, create new branch, commit, push, and create pull request in VS Code. Basically, all the steps required for you to create a pull request from start to finish. And it's only a very short 2-minute video with no chattering, straight to business. So I linked this video also in the WhatsApp group or along with the presentation PDF. This one. Oh yeah, one more thing I would like to add. If you look at the final website, you might feel intimidated that how was this built so fast, but Rome wasn't built in a single day. There has been countless number of errors and irritating bugs that I had to fix with the help of brainstorming and chat GPT here and there, which even that was giving a lot of wrong answers. So it was just one painful step at a time until the precious reward was reached. And there was one really small styling bug that was happening due to using Bootstrap styling. So basically, if I view this website on mobile, which I can just simulate over here, for some reason horizontal scrolling was coming. I disabled the overflow as I just put an overflow as hidden, overflow X as hidden, but still that was coming. That was because for this about section, I had applied the row class name for this div, and that was the root cause of all the error. So how I debugged it was select this arrow, see exactly where it was going wrong, select that div, go to styles and see that. This is a very useful tool for debugging when you want to make the website responsive on mobile, etc. Instead of directly opening the website on the mobile, you can just go to inspect, click on this icon over here, and you can see how the website will look on mobile. And here you can see the select the phone also actually. Let's say iPhone SE, iPad mini, many tablets also. So yeah, and if you go for responsive, you can actually adjust the rectangle also to simulate any device, any input pixel, the row into columns. Yeah, so any questions? Oh, by the way, this session has been entirely recorded. Tomorrow I'll edit the video and upload it on the YouTube channel and share the link for the same too. For those of you that couldn't attend or want to re-watch the session. Which laptop or computer do you use? This is a HP Pavilion. The exact model number I don't know, but it has GTX 1650 and Intel i5 9 Gen. It originally had 8 GB of RAM and 1 TB HDD. I upgraded it to 16 GB of RAM, added 8 GB more, and got an extra 512 GB SSD. So total storage that I have now is 512 GB SSD and 1 TB hard drive HDD. Before on HDD, to boot up the laptop, it used to take a good 10 minutes. Now it just takes 10 seconds, which is a monumental 60x difference. So yeah, SSD for the win. As part of the OS course last year, we had this Udemy course that we had to take. So I had also made a demonstration video for that. If you're interested in low-level system development and kernel development, I'll give the link to the channel itself in the WhatsApp group. Okay, one more question. How did you manage studies EL along with learning such skills especially in first year? Because this was all I used to do. But more seriously, I used to do like rigorous time management down to the exact minute, but not that strict actually. Plus minus used to happen, but I just set a general timetable like in this time frame I'll do this, in that time frame I'll allocate this, etc. So in that way I managed it. And plus that hunger and curiosity was there to learn more. So yeah, that helped. When you started all the Udemy courses, which did you think was the most tiresome? Which was the most tiresome? I think it was the... Okay, no, I'll get in trouble if I say that one. I think the most tiresome was the deep learning one because most of it was only theory, only maths, like how neurons work, the weights and biases, which most of it I felt was boring. But surprisingly, even the most interesting part was over there, like training our own artificial neural networks, recurrent neural networks, and convolution. Actually, buying the laptop for coding was secondary. Most of it was for playing games over here. Any questions? And the people who ask questions, feel free to ask questions again. It's not like you had only one question in your hand and you availed it. Okay, one more question. For a beginner, what would you recommend to start from? Or would you say to try everything and follow whichever you're interested, even though it is time consuming? I think this answer depends from person to person because some people shine when they stick to one particular field, and some people shine when they explore everything and then make something. So I think to answer your question, I think it would be to start from the fundamental. Like if you see a programming language like C, the fundamentals like loop, conditionals, boolean, etc. When you learn this concept in one language, learning another language becomes easy. The third language becomes easier. The fourth becomes even easier. So like that exponentially as you keep learning, the past knowledge that you have inculcated, it will be used to as a fertilizer to fasten the learning process for newer stuff. So because in knowledge everything is related to each other, so knowledge is never wasted. So you can start from anywhere actually, and when you go into the exploration, when you start exploring, you'll yourself get to know which things you're interested in and not interested in. So yeah, hope that answers your question. The second part was follow whichever we are interested in, even though it is time consuming. But if you're interested in it, then the more time you spend in it, the more you like it, right? So it's a win-win. Any questions or matter of fact, anyone wants to share anything, any opinions, feedback, etc. Most welcome. So I think we have come to the end of the session. If you have any pertinent doubts in your mind still, you can feel free to reach out to me on WhatsApp, LinkedIn, Gmail, Instagram, anything, and I'll always be more than happy to help you out. So I think yeah, with that we come to the conclusion of the session.
Thank you very much, Hardik. It was a really informative session, and I think a lot of people have learned a lot of things. And of course, anyone, if you're free, just feel free to hit up Hardik on his WhatsApp or anything, and I think he'll be more than happy to help. Is that right?
Thank you, Devam, for organizing, and Saga sir too. Yeah,
Hardik. Thank you very much, everyone. You can do.
thank you.
Thank you, Hardik, once again.